morning, everyone. So, my name is Runar, and I'm here to give you a brief overview of the tools ShipWeight and ExpressMarine, and also how they relate to ShipConstructor. Both tools are weight engineering software, and they are two complementary tools. ShipWeight is a tool that covers the whole weight engineering process, from early stage design, conceptual design, to basic design and construction all the way up until delivery. But ExpressMarine is less limited in its scope. It's a tool for basic design, 3D structure modeling of the hull and structure, but focus on the weight and CG calculation. So we're not talking about the 3D modeling tool for any details or any drawings or anything like that. And I'll give you an overview of these these two tools. Okay. But before that, just a couple of slides about who we are. So our company's been more than 20 years in the business of weight engineering, and involved in the shipbuilding and offshore industry with weight estimation, weight tracking, weight monitoring, and also weight and centrifugal during operation. We're a software company that is solely dedicated to weight and CG software development. And we are located on the west coast of Norway, Aasen, so that's why I have an accent on this. And our partners are ShipWeight USA, LLC in Annapolis, Maryland, and NDAR in Antibes, France. So ShipWeight USA and NDAR are resellers, and they also help with support and marketing while we are developing. Okay. Our users are all over the globe, but mostly in Europe and in the US. We have some users also in the Far East, but mainly Europe and the US, and it's used on a large variety of vessels, everything from Navy vessels to mega yachts, sailing yachts, passenger ships, fishing vessels, FPSOs, offshore platforms, anything that floats, you can use ShipWeight. And we have customers basically within every type of vessels that's been built. We have the pleasure of having some customers also locally here, both Oslo and English Shipbuilding are ShipWeight customers and ShipWeight users. So we're very happy about that. So let me dig into ShipWeight and give you a brief overview. So ShipWeight is a tool for all kinds of weight engineering, which means that it can be used in the very early phase, the concept design, and at this stage it's using parametric estimation based upon historical data. After the contract, you can further use basic design and detailed design, and in this phase, you have calculations and imports from CAD systems, imports from vendor rates, item libraries, and in the production phase, you monitor and weigh weights. And when the project is done, you have a weight database. This project is going to be exported to historical weight database and reused as historical lesson for new design, or used as a basis of parametric estimation for new designs. And as mentioned, it's a tool for all types of projects, and we are 90% into the shipbuilding and offshore industry. But lately we have also started to go into some other branches, because it's different constructions, but it's very similar challenges and that's the foundation of the software. That's where we store appropriate constructors, historical data, project data, handles logging and security. The input to the system can be manual, generic import, and also tailored imports. And calculations that can be done is parametric estimations, tracking, monitoring, and we also have several related functions beyond pure CG. And output, report, data dumps, tailor exports, all can be done in ShipWeight. So highlighting some of the main features, as mentioned, one of the core values of the system is the ability to do parametric estimation, where you do ratio between known parameters and rates for historical vessels and compare with your ongoing design. At some point we transition to tracking and monitoring. That can be more manual input that you would input to an Excel sheet, except you input of course to database with the relational database and all the advantages you have there. In addition to manual input, you can do data file import. You can import text files, Excel files, and Access files in a very flexible way. You can do some additional features and calculations of the system, like the weight distribution curve. We can produce moment, inertia, and radius calculations. We can visualize the vessel in Navisworks, in Rhino, and in the internal 3D tool visualizer. We don't have any geometry in ShipWeight, but that doesn't mean we can't visualize it in a 3D environment, because we simply plot the location of the weights, and if extensions are given in, we plot them as a square, and you can use it for visual checking, and sanity checking in QA. Monitoring means checking the development of the project from one revision to the next, monitoring trend lines, see how the weight of CG develops from one revision to the next, analyze where is the deviation, where is the weight going up, where is it going down, what is the impact on the total CG of the changes we are seeing. So this is monitoring and monitoring tools. And finally, we can deliver sort of tailored reports at the SSI or P12 reports, or any reports actually. Just create a template, report template, which you load into ShipWeight and then run up the report. This can be small reports for management, or it can be larger reports that you supply to the customer. So, what's the link between ShipConstructor and ShipWeight? A few years ago, we participated on an NSRP project, developing a tool called Fulcrum 3D. Fulcrum 3D is an agnostic tool that can be used basically between any CAD tool and any receiving weight interface. We were part of proof of concept in the project, and ShipConstructor was as well. We were both part of it. And Fulcrum was developed to do a smart import of CAD data from ShipConstructor model to the ShipWeight model for database. And when I say smart, I mean that you can do more than simply import data like you do from Excel. So the way this works is that the Fulcrum 3D will receive CSV files from ShipConstructor through the ShipConstructor publisher LT. And in the Fulcrum 3D tool, you would be able to set boundaries. You could define like items. So instead of seeing a list of a lot of simpler small items, you can see one line with a number of the items. And you can define assemblies. And also, in addition to import items, you would also get a list of items that would have been deleted out of the model. So not only to import data, but also a file that you would tell which items have been removed. So all of this was done in Fulcrum 3D, and then export an XML file that ShipWeight will consume, and through that XML file carry out the changes, adding new items, changing existing items, and deleting any items that have been deleted out of the CAD model will also be deleted automatically out of the weight model. In addition to having, as mentioned, the live items and assemblies. And now we're going forward by in ShipWeight now extending, or let's say implementing this functionality directly in ShipWeight. So we won't need to first get TSV into Fulcrum and produce an XML file and take that to ShipWeight, but we want to be able to consume the TSV files directly into ShipWeight with the same functionality as you have in Fulcrum, and then maybe add something more. For example, to update depending on maturity of items, whether items should go or not. So we want to make this process even easier in the future. Right, so that was ShipWeight very briefly. And then we have the new tool, which is called ExpressMarine. So ShipWeight we've been doing for 20 years or more. ExpressMarine is a 2-year-old tool, and it's a project for Rhino. And the main objective is to get from a starting point with the GA and hull form, and in no time get the 3D structure model to get the weight, the CG of the structure very early. And we're talking hours, maybe a couple of days to build up this model. And so we do it really fast with the sole purpose of the weight and CG. So we're sacrificing something here. We're not doing any details. We don't care how the stiffeners stand towards the shell. We don't care if the stiffener is normal or horizontal to the shell. Just in the grand scale of the weight and CG, it doesn't matter. And then we automate the creation of this structure through parametric modeling, which means that we can build up this structure without typically way you would typically do it by going to your CAD tool and start drawing, but you model it. So you start by importing the hull and GA, and then you, in this window here, start to define object by saying that, okay, I have an object, it's limited. It's located, its plane is located in this X position, it's limited by the hull. It's going to have these type of stiffeners spread out on it. It's going to have these kind of openings. So we give it everything parametrically and then create the object. And it gives you natural step your process of workflow to start then on the top and create the object that you can do just with the hull and referencing to some lines in the GA. And then you have objects which you can further use to define new objects. And this gives you associative topology. So the objects are related to each other. And this gives you the second big advantage, and that's flexibility. So if something changes, you can update the model really fast. And this associative topology is not just within the object of the 3D model, but each 3D model is also related to a trace that you pick to reference a 2D line on the 2D drawing of the GA. So if you get an update of the GA, if you go in and move a line in the GA, the corresponding 3D object in the 3D model moves along and updates along. So that gives you a very flexible way of working in the early stage. And the result, the output, is weight and center of gravity, looking go into ShipWeight. And you can get the small boom list with weight and center of gravity, and you can also divide the lesson into sections and export them into ShipWeight. But this is the purpose of the tool right now. But what we want to, so speed, flexibility, and applicability. It's all parametric, really quick, but because it's so quick, we sacrifice a lot of things, which means that, again, it cannot be used as any detailed modeling. But that doesn't mean that it can be the starting point of the detailed modeling. So what we want to embark on now is the development where we use this new Genesis tool in ShipConstructor to automatically export this model into ShipConstructor, so you can kickstart your ShipConstructor model with ExpressMarine and now start to work on your details. So today, I would say that if you've done the ExpressMarine model, you can't do too much about it. You can't import it to ShipConstructor, but sort of like a dead model, not a true ShipConstructor model. But we want to create an export link so we can export this and get ShipConstructor objects in the ShipConstructor project based upon this preliminary structure model here. Hopefully to save a lot of time. Alright, so that's what I wanted to present. Thank you for your attention. If you want to come by our table, we're happy to show you a demo of either of these tools. You can find more information on shipweight.com or expressmarine3d.com. So, thank you. Any questions?
I was very interested in the ExpressMarine development. So I'm just wondering, for finance element packages, is that an inspiration? You're looking at what finance element packages might be looking to integrate that structure model?
That's a good question. Thanks. That's the second thing that we are looking into, is to use this for FEM model. And I deliberately took it out of this presentation because I wanted to focus on ShipConstructor. But it's very true, because the problem with FEM today, at least many designers and artists, is that you can't bring the model quick enough. So when you have a model that you can do the FEM, it's too late in the design process. So that's definitely something we're looking into as well.
Any questions? Runar, one of the things we're dealing with right now, which one of the projects that will be briefed here tomorrow, is with the FEA, the detailing, right? That comes with the detailed design information that the FEA tools look at a non-detailed, or want to look at a defeatured model versus a fully featured detailed model. So they're even to a point where they're trying to defeature all the end cuts and some of those things. So I guess to the point, there may be some investigation from a standpoint of early on using that product to look at things from that aspect. Just thought I'd point that out. Any other questions, comments? Okay, thank you.